Number 20 for practice exam 2, the following density curve represents waiting times at a customer service counter at a national department store. The mean wait time is 5 minutes with standard deviation 5 minutes. If we took all possible samples of size n equals 100, how would you describe the sampling distribution of the x bars? Okay, so we have a distribution here that looks right skewed. But remember from the central limit theorem that if your n is large enough, and again, what we're doing is we're taking all possible samples of size n equals 100. So what we're doing is we're taking a simple random sample of 100, taking that average, and then another 100, and then another 100, another 100. And so because the central limit theorem tells us that if n is large enough, and the most minimum amount of n is 25, so if you have an n 25 or greater, then your distribution will look approximately normal. But for this particular multiple choice question, you have B and D as both true because the shape is less right skewed after it goes through more and more simple random sample of 100, more and more simple random sample of 100, and you take the averages of those averages. So that's why B is true, and the standard deviation becomes 0.5 because what you're doing is you're taking standard deviation of 5 divided by the square root of 100, so 5 divided by 10 is equal to 0.5. So D is also true because it correctly follows the the complete definition of central limit theorem, that the shape is approximately normal with me of 5 right there, and the standard deviation of 0.5. This is a mistake in the test. Shape is less right skewed. All that's saying is just it became more normal and not skewed. So that's how you do 20. And it's not A. It is right skewed right now, but because of the central limit theorem, it becomes approximately normal. And it's not C. C says shape is approximately normal would mean because the standard deviation part isn't true. It's not 5 anymore. It's 5 divided by the factor of square root of n, which is square root of 110. So that's number 20.